Hello and welcome to Sean White's Solar and Energy Storage Podcast. This episode, and for the next few episodes, we're going to talk about solar PV markets and applications. This is part one of part three. What we're going to cover is PV markets and applications for grid-tied PV with and without batteries, voltage sags, voltage peaks, California Rule 21, energy storage, smart electronics, bidirectional electric vehicles, UL 1741, UL 1703. We're going to talk also about CE, that's how they list things in Europe, the National Electrical Code, that's the NEC, anti-islanding, standalone inverters, multimode inverters, microgrid interconnection devices, that's an MID, interactive inverters, solar in space, also called space-based solar power, that's SBSP, I'm into space, portable solar power, hybrid, utility scale PV, distributed generation, also known as DG, concentrated PV, concentrated solar thermal, and we're going to talk about solar thermal versus solar PV. To find out more about solar and energy storage, go to solarsean.com. On with the show. Some markets and applications technology. First of all, what we're going to do is just kind of briefly go over the different applications for PV. Then we're going to go into it in a little bit more detail once we go through it briefly. First of all, we're going to talk about grid tied. Utility interactive grid tied without batteries. It used to be when PV was just a small little fraction of a percent not too long ago of the energy mix. Most of our inverters out there that are grid tied, they turn off whenever the grid, say, has a sag in voltage or a peak in voltage. And so if the voltage sags and a little fraction of 1% goes off the grid, not a big deal. But if you have half the grid powered by solar and there's a little sag in voltage and then half the grid turns off, that would be a not good thing. And that's something that they're worried about in different places where there's more penetration of PV, such as in Hawaii and Germany. And also other places such as California is starting to come on. And that is changing very fast right now. As more and more solar goes on the grid, we have to learn how to deal with the fact that a lot of times we don't want all the solar to turn off all at once. In California, they have a requirement called Rule 21, which is material for our advanced class where the inverters don't turn off so easy. And in other places, energy storage is also part of the mix to deal with this problem that doesn't have to be a problem, as long as we take proper precautions using our smart electronics. And pretty soon, there will be bidirectional electric vehicles which will be able to do a lot to help with this. If you're interested in getting more detailed about the advanced technologies such as bidirectional electric vehicles, I recommend taking my 40-hour advanced course, or you can also get an idea of what's going on by looking at our free class called Solar Building Codes, Fire Codes, EVs, Rapid Shutdown, and Energy Storage System. That's a 2-hour free course that you can sign up for on HeatSpring. But hey, let's get through the basics first. We've seen a lot of evolution with PV lately. What we're seeing is the past had a lot to do with energy storage. So the old-time PV systems, they had batteries. It was too expensive to feed the grid with PV. It was only used for places that didn't have power lines coming to them because people don't like to spend $1 million powering their far-out ranch in Montana. Then we had the price of PV go down and incentives, and then we had a lot of grid-tie PV. However, with greater concentration of PV on the grid, and energy storage prices falling fast, a lot of that has to do with electric vehicle mass production, bringing the cost of lithium batteries way down fast, kind of like how solar prices go down way fast. We are seeing energy storage coming onto the scene very fast. Still, there are a lot of arguments to not have energy storage with your PV system, but the arguments for having energy storage with the PV system are getting stronger financially. Right now, we are in a transition time. You hear people at the solar conferences say that energy storage is the new PV. As I am recording this right now, I am putting together an energy storage bootcamp course. Most of you are interested in passing the NABCEP associate exam, and exam questions aren't going to be right on the cutting edge of what is happening in the industry. So plain old grid-tied solar without batteries is very common, and it goes off when the grid goes down. So it's good to know most of the time when the grid goes down, you can't power your house with a PV system. you pretty much, with a couple of exceptions, need batteries to do that. If you're selling solar or talking to your friends about it, don't tell them that their PV system is just going to power their house when the grid goes down without knowing that it's going to be an extra cost to add batteries. Sometimes it doubles the price of the system or even more, especially if somebody wants to just completely disconnect from the grid. They're going to pay at least triple and still end up with less energy if you want to just defect from the grid. And some people do that on principle alone. It's not financial principles, by the way. Historically, perhaps some questions you might see on the NABCEP Associate exam, which we'll cover multiple times, are one of them being that UL 1741 is the UL testing they do for all inverters. Also, combiner boxes, charge controllers, microinverters, and DC to DC converters, also known as optimizers. So just be aware, pretty much for your PV electronics and your grid tie electronics, you're looking at UL 1741. So that's kind of an uncomfortable number that you just have to memorize a number. That's kind of fun. Also, just by the way, while I'm here, I'll mention that UL 1703 is the listing for PV. Those are a couple of numbers that you might have to memorize for the NABCEP Associate exam. That is UL 1741 is for the electronics, and UL 1703 is for the PV. It's written on the back of the PV. And not everybody here is studying in a place where we adopt the National Electrical Code. So if you are in a different country, a lot of times you're going off of different requirements, different listings. The one that you see in a lot of other places in the world is CE, and that's in Europe and a lot of other places where they use that. Some places, they don't care. And you can't take different things from different countries and install them in different places. So if you're following the NEC, that's where you need to go for the UL listing. And you might say, what countries use the NEC? Well, the United States primarily uses the NEC. There are a lot of Latin American countries that also use the NEC. The Canadians also look at UL listings, and they use the Canadian Electrical Code. That's the CEC. And in the Philippines, they've copied the NEC, and they call it the Philippine Electric Code. The NEC, by the way, is the National Electrical Code. It is way advanced. Let's get back into the basics. Other things to know about grid-tied PV is that it goes off when the grid goes down. We already mentioned that, but that could be something that you would see on the test. And on the test, they might call it anti-islanding. Anti-islanding means it disconnects from the grid when the grid goes down. That means that you cannot become an island of power. On the other hand, if you have an off-grid inverter, also known as standalone, then it would be able to do islanding. So remember, anti-islanding means it disconnects from the grid when the grid goes down, and islanding means it can work without a grid. It can be its own island of power. That's off-grid, standalone. Some inverters have two separate outputs. One can do islanding for backed up loads, and the other can do anti-islanding for a grid-connected output. We call those types of inverters that can do both, we call them multimodal inverters. So we have standalone inverters that can do islanding, interactive inverters that do anti-islanding, and multimodal inverters that can do both, with separate outputs usually. Once in a while, you might see an inverter that can do whole house backup using a microgrid interconnection device. And with a microgrid interconnection device, it is possible to have a multimodal inverter with a single output. A microgrid interconnection device is not something I would expect on the associate exam, but the other things that I was talking about, islanding for off-grid inverters that you might like to have on your own island, anti-islanding for grid-connected inverters, and multimodal inverters, those are things you might see on the test. And anything that you might see on the test is something that I will cover multiple times. So if you don't have it memorized right at this second, stay tuned. We're going to cover this again, upside down, inside out, and sideways. So remember this. The official word for grid tie is interactive. So it's called an interactive inverter in the National Electrical Code. An interactive inverter versus the other types of inverters that we're going to talk about a little bit later. Next on our list, we have standalone, also known as off-grid, also known as battery-based, also known as remote. These types of PV systems are made to work without any utility at all. The official term for these systems, as in the NEC, is standalone because they stand all alone. However, off-grid is the common term that you see a lot of people use. Also, you can see people talk about battery-based. However, batteries could also be connected up to the grid. And they are remote systems oftentimes too, because the reason that we have a standalone system that doesn't connect to the grid is because we don't have a grid nearby. That's why people will buy a standalone system. It's nice to connect to a grid when possible, because then when we have extra energy, we can get credit for it by sending it to the grid and helping out our neighbors with those electrons. The part of this industry that is growing fast, and it's all the talk of the town lately, is grid tied with energy storage. So we're putting a lot of solar on the grid, and the solar needs to be stored because it only comes out when the sun is up. When solar is a small part of the grid, it's not that big of a deal because the grid can use all of your solar energy. But now, as solar is getting cheap and taking over, we need to be able to take some of that solar energy and put it into a battery. There's lots of different ways of doing this. We can put that solar into a battery at our house. We could put that solar into a large battery on the utility, and we could even put a battery on our house, depending on the policy of your utility, that is not even directly connected to a solar system. Much of the time when people do put batteries on their house that are primarily there to deal with grid electricity, we can also set those systems up to work with backup. I mean, hey, you already have the battery there anyway. Why not work with backup? Especially in places like in California where there's been fires and they have public safety shutoffs in the summertime when there's a fire hazard so the wires don't fall over and start burning trees. So that's solar and storage. Next on our list, we're just going to talk about this very quick. Solar is how we power most things in space. If we look at those satellites that's sending all those signals down to your phones, that is solar in space. And I also mentioned briefly that there are businesses out there that are focusing on beaming the energy back for use on Earth with the space-based solar power. That's it with space for right now, because now we're going to talk about portable solar, not something that we're going to talk a lot about. I have a voltaic backpack that I carry around that I could charge a phone with. Gets a lot of talk when people say, hey, that looks kind of neat, especially the people that check my bags at the airport. We can see some things that are set up for highway signs and speed traps. And so we have portable solar. A lot of times with portable solar, they work on 12-volt systems. So you would count 36 solar cells charging 6 lead-acid battery cells, and that's a 12-volt system. Count the cells on your next parking meter excursion when you see a parking meter or a trash compactor that has solar on it. See if it has 36 cells. And then our next application that we're going to talk about here is hybrid. And this is a term that has different meanings. In the National Electrical Code, hybrid means something that has perhaps solar or wind and some other form of electricity besides utility or battery. And that's right, I said besides the battery. So a battery does not make a hybrid system according to the National Electrical Code. But in the industry, most people say hybrid and they mean solar and batteries. So just be aware, if it's a test question, they're going to follow the National Electrical Code, and hybrid does not mean battery on the test, but hybrid means battery on the trade show floor or when you're talking to your distributor. Quick examples of hybrid systems would be PV and wind, PV and a generator. Most off-grid systems are hybrid because they do have generators for when the sun is not there. Typical inverters that work with batteries would be called multimodal. And now utility scale PV systems. Those are the big ones, giant PV systems. Some people might define a utility scale PV system as 5 megawatts and larger, but it just depends on who you're talking to. And we say utility scale because it's not always the utility owning the PV system. Most of the PV in the world is utility scale. When you look at the numbers, how China has so much solar installed, that's almost all utility scale. When you have solar that's not utility scale, when it's on a rooftop, that means you make it where you use it, and that's called distributed generation, or DG for short. A lot of times you'll see people talking about DG. Concentrated PV is a thing of the past, so we won't get too much into that. Back when PV was super expensive, what they would try to do is focus sunlight onto a solar cell with mirrors and lenses to try to get more for their money. Now, with PV prices being down so low, you just don't see concentrated PV anymore. Concentrated solar thermal is not PV at all. You'll see pictures of giant solar power towers, and they'll have a whole bunch of mirrors shining on this tower, heating up things, and then making steam to spin a turbine. So I just wanted to let you know that that is not PV. It's kind of neat. But PV prices went way down around 2008, and not too many people are investing in concentrated solar thermal anymore after that. And another thing to mention is there's solar thermal that's just hot water. You'll see a lot of that in Hawaii and in China, but now PV is so cheap that that's replacing a lot of the solar thermal. You don't have to do plumbing. Electricity is a lot more solid state. That means you don't have things flowing and pipes and valves opening. You just have switches and circuits. That's right, the future is here, folks. PV. Discipline yourself and study a lot. We want you to pass. Thanks for listening to Sean White's Solar and Energy Storage Podcast. This was PV Markets and Applications Part 1. Get ready for Parts 2 and 3 the next couple of weeks. And to find out more about solar and energy storage, go to solarsean.com.